Suppose marketing experts have determined the relationship between the selling price of an item and the quantity sold of an item can be represented by the linear equation Q is equal to negative 30s plus 800, where Q is the quantity sold in a year and S is the selling price. And that makes sense. If our selling price is higher, then this whole thing is going to become more negative and we're going to sell less. And if we lower our price, we're going to sell more. Fair enough. They tell us if the cost to produce the item is $20, what is the selling price that optimizes the yearly profit? So let's think a little bit about what yearly profit means. Let's think a little bit about yearly profit. The profit is going to be equal to the quantity that you sell, right? The quantity that you sell times what? Times, for each unit, what you care about is the profit per unit. And the profit per unit is the selling price per unit. It's the selling price per unit minus the cost of producing that unit. So the cost of producing the unit right there is $20 minus $20. And that makes sense. If you're selling something for, say, $30, and it costs you $20 to make it, every unit you sell, you'll make $10. 30 minus 20. If you sell 2 units, it's going to be 2 times $10. You're going to make $20. So nothing really, nothing groundbreaking right here. Now, right now we have profit as a function of Q, of quantity, and selling price. But we have quantity as a function of selling price right here. So we can substitute this whole expression right here in for quantity. So what happens to our profit function then? So then we can rewrite our profit function as being equal to, instead of writing Q, we could say it is the same thing as negative 30s plus 800, negative 30s plus 800 times s minus 20. And let's multiply this out so we have a nice clean trinomial. So if we have our profit is going to be equal to negative 30s times s is negative 30s squared. Negative 30s times negative 20, that's positive 600s. 800 times s is 800s. And then 800 times negative 20, 800 times negative 20 times negative 2 would be negative 1600. So it's going to be negative 16,000. So it's negative 16,000 if I did it right. 800 times negative 20 is negative 16,000. So this right here is our profit function. And we can merge these middle two terms right here. So we have our profit is equal to negative 30s squared plus 1400s, just merging these middle two terms, minus 16,000. Now, we have a negative coefficient on the s squared term, which tells us this will be a downward opening parabola. And so let's think a little bit about it. If this is our profit axis, if that is our profit axis, and this right here is our selling price axis, this parabola is going to look something like this. I don't know exactly what it'll look like, but it'll look something like this. It'll be downward opening. And we're asked to find the selling price that optimizes the yearly profit. Well, it's optimal if it's as high as possible. So we're going to look for a maximum point. We're going to look for that maximum point right there. Find the selling point that gives us that maximum point. And we've seen this before. That's the selling point, or the s coordinate. That's the s coordinate of the vertex. We need to find the s coordinate of the vertex. And the easiest way to think of doing that is to kind of put this function into our vertex form. So let's do that. And the easiest way to do that I can think of, well, we're going to do a little bit of completing the square and all that, but we've seen all of this before. Just take it step by step. So the first thing I like to do is factor out the negative 30, so we have a clean coefficient on the s squared. So we could write price is equal to negative 30 times s squared plus, well, actually negative, so 1400 divided by negative 30 is negative 140 over 3. You can divide both by 10. S. And then 16,000 divided by negative 30 is positive 1600 divided by 3. You take a 0 off of each of those. You have a negative divided by negative. They cancel out. And that's what we're left with. And actually, let me write this positive 1600 over 3 a little bit further out. So plus 1600 over 3. All I did so far is I just factored out this negative 30. What we can do now is we can add and subtract a term here so that the first 3 terms here become a perfect square trinomial. That way we can get into that vertex form. So what do we add and subtract? Well, 100, negative 140 over 3, negative 140 over 3 can be rewritten as 2 times negative 70 over 3. So what you want to add and subtract is negative 70 over 3 squared, or half of negative 140 over 3. You want to add that squared. So plus negative 70 over 3 squared. And we can't just add it to one side without doing anything else. So let's also subtract it from that same side. So minus negative 70 over 3 squared. So we really haven't changed the equation at all. We're just adding and subtracting the same thing to both sides. But what that allows us to do is to make this into a perfect square trinomial. This is a perfect square trinomial. So we can rewrite our profit function. Our profit function is equal to negative 30 times this thing right here, which is a perfect square. It is s minus 70 over 3 squared. And then we have all of this business over here. Minus negative 70 over 3 squared plus 1600 over 3. Plus 1600 over 3. Now the next thing we can redistribute this negative 30. Let me scroll down so we have some space to do this with. So we could say price is equal to negative 30 times this expression right here, 5 minus 70 over 3. Oh, sorry, not 5 minus. That's an s. Have to be very careful. That's our selling price, s minus 70 over 3 squared. And then that's negative 3 times this first term. And then we have to multiply negative 3 times negative 30 times each of these terms. So then was negative 30 times this. A negative times a negative is a positive. 30 divided by 3 is 10. So it's going to be plus 10 times negative 70 squared. 10 times negative 70 squared, which we could evaluate if we want. And then negative 30 times 1600 over 3, it'll be negative 10 times 3, it'll be negative 16,000. Negative 16,000. And this is, we can simplify this. We can add, we could fit negative 70 squared is what? It's positive 4,900 plus times 10. You get 49,000 minus 16,000, which is what? This is 33,000. So we might as well do that. So this whole thing simplifies to our profit function. Our yearly profit is negative 30 times s minus 70 over 3 squared. And let me make sure I did that right. 7 times 7 is 49. And then you have, no, it's 4,900. Let me be very clear here. Oh, no, yeah, 7 times 7 is 4,900. And then times 10 is 49,000. Right. Let me make sure I got it. Yep, 49,000. 49,000 minus 16,000 is 33,000. So plus 33,000. Just like that. Now, when is this thing maximized? When is this thing maximized? Well, if you look right here, this term right here, this s minus 70 over 3 squared is always going to be positive, or it's always going to be non-negative. It could be 0. And so when you multiply it times a negative number, it's always going to be a negative. So this thing is always going to be non-positive. Non-positive. It could be equal to 0. So the profit is going to take its highest value when this whole expression is 0. And when is this whole expression going to be 0? Well, the whole expression is going to be 0 when s is equal to 70 over 3. When s is equal to 70 over 3. That's when it equals 0. And just so we have a better sense of that, what is 70 over 3? So that is what? 3 goes into 70. 3 goes into 7 2 times. 2 times 3 is 6. Bring down to get a 10. 3 goes into 10. 3 times 3 is 9. Subtract. And then you get another 10. So it's 23.333333. You could view it that way. It just keeps repeating. Or you could say the ideal selling price is $23.33. So the ideal selling price, the maximum selling price, the selling price that optimizes our profit, the selling price that optimizes our profit is $23.33. And when you do sell for $23.33, this is going to be 0. That whole thing is going to be 0. And your profit is going to be $33,000. So at that point, your profit is going to be $33,000 for the year.